Hello everyone, welcome back to my channel. Today in this video, we will continue from where we left off in the previous video. We will examine the practical side of RF survey, and to be more precise, we will only focus on the predictive RF survey. Now, instead of listing down the steps required to design a WLAN in a facility, I have compiled a WLAN design scenario that we will go through together till the end. I'll take advantages of this WLAN design task and explain or demonstrate these objectives. For now, let's go ahead and read our design requirement task. So we have a concert hall facility that was made up of different ceiling heights, 3 meters and 10 meters. The concert hall itself, it's 10-meter high, while all other offices are 3 meters high. We have to provide both voice and data services over WLAN in the entire facility. We need to exclude bathrooms and stairs from the WLAN coverage. The customer doesn't care about coverage inside these areas. Also, the customer expects the following number of users in each concert event. So around 580 visitors inside the concert hall area, plus there are 45 employees running the facility. 25 of them will have wireless IP phones to communicate over. Now, these are our requirements. Let's dig deeper in each one of these in order to understand and imagine what kind of environments we are designing for. So in the first place, this is a concert hall facility. The customer has already provided you with its layout. Let's have a look at this layout. So this is a 2D view layout inside the AutoCAD. Basically, you can see three separate coverage areas that we can consider. The upper offices part, the concert hall in the middle, and the lower part also consists of offices. In the requirements, it was mentioned that all offices are of 3 meters height, while this one, the concert hall, is 10 meters height. So this is a 2D view. Let's try to Google such an environment in order to understand what or how it looks like. So concert hall. Let's go to images directly. For example, let's look at this. Let's look at this. Okay, so this is an example of a concert hall area. You can see chairs. It's very similar to this one. And you can notice that the height as you go from this point to this point to the ceiling differs. Same case applies here. If you go from this point to this point, the height would differ. So we can't say that all ceiling heights that we're designing for inside the concert hall would be 10 meters. It could be 10 meters, but it could be less. So if you are a user sitting here, then the access point above you could be above 10 meters or around 10 meters. While if you are sitting in the back, then it could be 5 meters. So these changes in the height, we need to take care of them in our design. We will see that in action in our Ekahau design demo. So for now, I think we have a good view about our environment. Let's see the next step. So the next step is talking about the services running over Wi-Fi that the users will be consuming. So we have to provide voice and data in the entire facility. In order to do that, we have to serve an X67 dB signal strength at each cell edge, while we need to maintain a 25 dB of signal to noise ratio in all areas. Furthermore, the data rates that are required for stations or wireless devices to associate to the WLAN is set to 12 megabit per second. We can set it higher, but for the sake of our demo, let's just assume it's 12 megabit per second. Okay, let's see what other requirements we need to look after. Here, we need to exclude bathrooms and stairs. I'll show in Ekahau how we can define areas of interest and exclude others or part of areas of interest. The other requirements, it's all about the number of users that we need to serve over Wi-Fi. We have 580 plus 45 employees, a total of 625 users. Does this mean that we are going to design our Wi-Fi in order to support a total of 625 devices? Let's see. Let's have a quick capacity forecast for our design. The customer already mentioned that the number of users are these numbers. The keyword that we need to focus here is user. So if we ask ourselves, in a capacity forecast, what does a user refer to? The user could refer to one mobile device or one mobile device plus one laptop or two mobiles plus laptop, etc. So it could be a user owning one mobile or two mobile devices or three mobile devices, etc. Which option to select for our capacity forecast? The answer, it depends on the environment itself. I'll explain that in a minute. For now, if we consider the first option, we will end up having 580 devices inside the concert hall. The same case applies for the offices. We will end up having 45 devices inside the offices. If we select the second option, then we will end up having 1,160 mobile devices inside the concert hall only, while we will have around 90 mobile devices inside the offices, and so on. So math is easy. You can always do it. Again, which option to select for our capacity forecast? The answer, as I said, it depends on the environment itself. So let's see the environment. So this is our layout. Actually, let's open it in a 3D view. Let's go to the same environment we selected previously. The question is, why on earth do you think that someone would come to such an area to listen to music, would bring his or her laptop for work? No one would do that unless that person is from an IT support staff. Just kidding. So the conclusion that we could think of, we usually don't expect to see more than one mobile device per user in such an environment. So for concert hall, we will be using the first option. Let's go to the offices. Offices environment is different. So we would expect to see one mobile device plus one laptop for each employee. Therefore, we will be using the second option for our office's environment. Based on this discussion, let's see how the capacity forecast would develop. For the concert hall environment, there will be 580 mobile devices plus X. X is just another number of devices that could be added to accommodate our future expansion or future additions of devices. I have selected that to be 50 just for the sake of our, it's random selection for the sake of our demo. The total number of devices will be 630 devices, and these devices will be capable of supporting one spatial stream only. Most mobile devices we hold in our hands will be one spatial stream. Except I think Samsung S10 and the latest Apple device, they are capable of supporting two spatial streams. For our demo, let's consider all of them as one spatial stream. For the offices area, we will consider it like this. We will count 45 mobile devices per user, adding to that 45 laptops, and as stated here, 25 wireless IP phones. The capabilities for these devices actually differ because mobile devices are capable of supporting one spatial streams, while laptops can be 2 or 3. I have selected to design for 3. And most of wireless IP phones can support 2 spatial streams. The total number of devices in the offices area will be 115 devices. These devices will be of varying capabilities. We need to take that into consideration in our design. I'll show that in Ekahau. With that said, we have wrapped up our Understanding Your Environments video. In the next video, we will use Ekahau in order to perform the predictive design. Thank you for watching.